Hi dear students, we are going to discuss today work, energy and power. Very short answer questions and short answer questions, long answer questions which is mostly asked in CBSE and state syllabus. First, very short answer questions. Very short answer questions. Question this is 11th question, which is already we made a video from Physicsframesgrb, which is important questions. 11th question, define work, power and energy, state their SI units. Work definition. So work is said to be done by a force when a body undergoes displacement in the direction of force or in the direction of component of force. Components means two components, that is horizontal component and vertical component. SI units is Joule and dimensional formula is m power 1 L power 2 T power minus 2. Power. The time rate of doing work is called power. Power is equals to work by time, or SI unit is joule per second or watt. Dimensional formula is m power 1 L power 2 T power minus 3. So this is the definition of power with the SI units and the formula and dimensional formula. Energy. Energy of a body is its capacity to do work, or SI unit is joule and dimensional formula is m power 1 L power 2 T power minus 2. So energy, dimensional formula, potential energy, kinetic energy, any sort of energy or work will have same dimensional formula. Now conversions, 1 watt is equals to 10 power 7 erg per second, 1 horsepower is equals to 746 watts, 1 kilowatt is equals to 1000 watts, which is equals to 36 into 10 to the power of 5 joules. 1 megawatt equals to 10 to the power of 6 watts. If you write the conversions, it is a benefit for you to get the complete marks. Next question, 12th question, which physical quantity remains constant in elastic collision? In elastic collision, the total momentum and total kinetic energy remains constant in elastic collision. If momentum and kinetic energy are conserved, we can also call it as elastic collision. Or if you want to write an extra point, we can say that after collision, if the both bodies have different velocities, then it is called elastic collision. The total momentum of the system only remains constant in inelastic collision. So if total momentum of system only remains constant, that is only conserved but not kinetic energy, then it is called inelastic collision. Or in a simple way, we can say that after collision, if both bodies have same velocity, then it is called inelastic collision. Next, work, power, energy. Short answer questions. First one, what is potential energy? Derive an expression for gravitational potential energy. Potential energy of a body is the energy possessed by a body by virtue of its position or configuration. That means if it is at a certain height, it will have potential energy. Example, water stored in a overhead tank. That means water will be stored a certain height. So due to its height, if it is rest, it will have potential energy. Or energy in a stretched rubber band. If you stretch it as it will be expanding, and if you leave, it will contracts. This is also the best example of what? Gravitational potential energy. Now you can see a body here, a body of mass m is resting on horizontal surface, and the weight of it is acting downwards, and force is acting vertically upwards. That means if you pull that body which is in the upward direction to a height of h, then consider a body of mass on the ground. It's lifted vertically upwards through a height h. Considering the height h is very small compared to the radius of the earth, we can neglect the variation of g. See, radius of the earth is 6400 kilometers. So whatever we are lifting height should be very, very less when compared to the radius of the earth. Then only we can consider this expression. See here, the gravitational force acting on the body is mg, that is, which is vertically acting downwards. The work done by the external agency again is the force. That means we are applying a force to lift the body against the gravity in the upward direction, where force and h both are in the same direction. So here work done can be written as Fs cos theta, which is nothing but theta is the angle between force and a displacement, that is F and H, which is nothing but theta. So theta is 0. So Fs cos 0 is 1, which is nothing but Fs, which is work done. Now F is equal to mg and displacement is h, so work done can be written as mgh. This work is stored in the form of potential energy of the body. The potential energy of the body is U is equals to mgh. Hopefully you understood this one. Like, share, subscribe for more videos, more and more videos. All the best for your examination.